present at the time of presentation? 16:30. 4:30 p.m. 16:30 hours. And you have to present in teams, 2 teams. Decide yourselves. One team for procurement, another for distribution. And scope for improvement in West Bengal. Okay. Now we shall start for the next session on rice milling details by Srinivas. Please.
Good afternoon. I don't know what mistake I did because my lectures are always after lunch. So the job of trying to keep you awake is always on my shoulders after lunch. Oh, thank you so much. That's the best compliment that you could think of giving me. Now, the ball is in your court as to how long you want me to talk on this subject. 30 minutes or 45 minutes or 1 hour or 3 hours or 3 days, I'm ready. So the ball is in your court. So let me know how much time I would be given, as fast as possible. Okay, as long as the course director allows, that's also fine. Yeah, basically, let me get a feedback from you of how many of you have seen a rice mill? Please raise your hands. Actually seen a rice mill in working condition. Okay, that's about 80-90%. That's good enough. Then I think it will make my life a little easier. Otherwise, it will be a little difficult. Now, why do you think rice breaks? Where is the reason? I would like you to kindly give out your opinions. And anyway, this is not a class. We don't belong into that sector of a lecturer and a student. I think mutually we would like to share our experiences.
Firstly, due to high moisture content of ID.
Beautiful, sir. That's nice. High moisture content. Then, sir, let me put this in a slightly different way. Before these web services and matrimony.com came in, how, I think most of us belong to that category. How do you think we chose our wives? How? Matchmaking was Kundli, right? So there was a lot of science involved in it, but over the ages it has been lost. The Kundli usually would give what is the character of the girl, and if I'm a boy marrying a girl, or if a girl is marrying, what's the character of the husband, what is his lineage, so genetic engineering, and then what is the fact whether these two people are matched, compatible for each other, and things like that. So that was taken into consideration, and then later on we had this online services. So even for breakage of rice, its Kundli is very important. So right from Dr. Sheikh Mira's expertise of which variety, what is its gene, how it was, up to all the 6 checks that he had done, or 8 checks he had told about, all those things determine whether this paddy is going to crack or not. You'll be surprised when I show this and say that this is the areas in which rice is milled either as raw or parboiled. So I cannot find where West Bengal is. It's covered with so many dots of parboiled rice milling units. So now there are 2 things. Now we have rice which is raw, we have rice which is parboiled. Now why do you think parboiling came into picture? It came in because those varieties of rice, when they were milled raw, would give the highest amount of brokens. So the best way was to heal up or iron out all those brokens was to make it into parboiled rice. Look at the grain itself. It is a tough grain by itself. It's not a very weak grain. And milling per se will not break the grains, but it only makes those cracks which have been formed previously manifest into brokens. So, if you, I will give you a small different way of looking at the system. Yesterday we were talking about the roller flaker. We soak the grain, we heat treat it, then it becomes soft and pliable. We put it into a roller flaker and then it converts it into flake. When we were designing that machine, that was my first job as soon as I joined this institute. So we wanted to know what is the force on the rolls. So from there I can design the components of the machine. Then we took each rice grain and we have a system to measure the hardness of the grain. So when I press it between two steel plates, can you just imagine what is the force required to press one soft grain of rice into a flake of 0.4 millimeters thickness? Can you guess what is the force required? Now come up with some figures. I know you will be right or wrong. That's it. Just trying to initiate a dialogue. Yes, sir. You can hazard a guess. Just that. That's okay. There are no marks for getting wrong answers.
This will be given in scientific terms.
No. I'm asking you how much kg force is required to press one grain of rice. Only one grain of rice. What is the force required to press one grain? I can bite it with my teeth. Right?
What is the force of lifting?
Yeah, exactly. Now that's what I was coming to. See, I was surprised when I found out that each grain of rice needs 100 kg force to press it into a flake of that thickness. So when I put one beside the other and I have so many rice grains on that roller flaker steel roll, the force on that steel rolls was something like 60 tons. So that from there we designed the machine. That would require about, for 300 kg per hour, I would need about 30 HP. 300 kg per hour, I need 30 HP. And God was such a beautiful engineer that He has designed a fulcrum here and the force is applied here. Force into distance is moment and therefore I am able to bite rice. So rice is not weak, it's a very strong grain. As it is very strong. So this is what I was trying to say. So the moisture, the environment, the type of grain, whatever Sheikh Mira was going to give us, the type of grain, and lastly the mill type. So these are basically the factors. Now reasons. I have 12 reasons. So all of these are responsible for breakage in rice. So you can rate them one by one. Cracks in the kernel, which is already there, because why cracks come, we'll come to that. Immature grains, if there are there, yes, we'll have them. Moisture content of paddy. Yesterday we had Mr. Subhash from FCI. Please remember, each stack is about 1760 bags of paddy. In a cap storage, we had 1760 bags of paddy. The ones in the center, the bags in the center have got the higher moisture content as compared to the ones on the outside. And the entire lot is coming to my rice mill as one lot. So my machines are not geared to handle variations in moisture content. And that happens. And therefore you have brokens. And within the kernel also, you have moisture difference. And therefore, brokens will come. And degree of milling, see, all of us, pardon me madam, all of us want Aishwarya Rai to be our wives. Right? Why? Always my wife has to be beautiful. For somebody else to look, why I should be bothered? So similarly here, the idea is to always have rice which is white in color. That is one concept that has come into it. So therefore what the miller is doing, is trying to remove more and more grand layers to make this grain appeal to the customers. And in the process, he is putting more force on the grain and therefore you have more brokens. Then the grain shape. So if it is basmati rice, please don't expect anything more than 45-50% as your head rice yield. If you get that much itself, you have the best milling techniques. And there are certain grains which are round in nature, but they are chalky in the center. So chalky means they are not fully developed kernels, and therefore they are softer than the outside. Therefore, breaking occurs. Grain thickness. So you have variation in thickness, kernel chalkiness, and the type of equipment that we use, and number of stages in which we are going to do the milling. And if you have insect and fungal damage, then yes, you have it again. Age of paddy. That also plays a role. And then other miscellaneous factors as to why and how, we'll just try to see in a little detail. So let me sum it up by putting it into these 5 categories. So variety, the time of harvest, drying, parboiling and milling. So these are the 5 major factors under which we can think of why breakage takes place. Variety, yes, I think we've had a lot of discussion on this subject. So which variety is good, its dimension and chalky varieties, and even the fertilizer usage and timing has a role to play on how this grain is going to form. And its structure is so unique that if it is not properly, the fertilizer is not properly used at the right time, then we'll have inherent defects in it, and that leads to breakage during milling. Harvest time. So you can see that the cracked grains are in the black line, the shelling breakage is in the red line, and the paddy yield is in the blue line. So you have to find out the optimum stage at which harvesting has to be done. There was this Regional Extension Service Center for rice milling in 14 states of the country, which was sponsored by the Ministry of Food Processing. Now all those centers are closed, and these centers were basically meant to disseminate information about rice milling to the end users. So when we used to go to different states, and our institute was one of the centers where we had it in Karnataka, and we used to talk to all the millers in Karnataka. Then we used to tell them, look, you kindly educate the farmers. We used to tell the millers, you educate the farmers as to when to harvest the paddy. The optimum time was when you have 1 or 2 grains in the panicle which are milky. You harvest at that time, right sir? And after harvesting, what do they do? They allow it to lie in the field for a couple of days so that shedding is easier. Now in this process what happens is the grain is still alive, the plant is still alive, so the nutrients are supplied to these milky kernels, and even they turn into solid grains. And therefore the milling yield will be much better. Suppose you wait until even the last grain in that panicle turns yellow, the ones at the tips have already become over mature, and then alternate wetting and drying because of night and sun would create cracks, and that will break. So this was also disseminated to people. So harvesting time also has a role to play, and for this mistake the miller is paying the price. No fault of his.
Can they find by seeing the paddy? Because miller is not producing. He has to, by seeing paddy, can he say when it is harvested?
he can tell when it is harvested, but the farmer needs to be told that you have to harvest maybe a couple of days before than his normal routine. So you should have 1 or 2 grains which are milky. At that point, if he harvests, then yes. There are quite a few things that take place in this chain of from the farm to the miller. Now, if you talk of the quality also, now in quite a few places there are instances wherein they check the quality of the rice before taking it, even for PDS also, and for general milling. Then they do a quality check on it. So that is also possible. And for that purpose also we have devised what is known as a paddy crack detector. So it is not a mental crack detector. But
by accepting paddy for PDS for MSP, we check moisture content and other physical parameters like boulders, etc.
exactly for that reason, we have designed one paddy crack detector. And now shortly I am coming out with a handheld unit, which is battery operated with LED lights. Yes, sir. There are a lot of reasons as to why these things happen. But at least if we are aware that, okay, if it is harvested at this time, it's going to give me more yield, then I think half the job is done. Exactly. Availability of laborers have to come. Now people are moving into machines, combine harvesters. And then combine harvesters have some problem. They are designed for wheat, not for rice.
What is the battery?
It's a paddy crack detector. You take 100 grams of, 100 grains of representative sample of this paddy, put it on this meter, and you can see through it like an X-ray.
Where you find it?
We are doing it, so give me some time to finalize that. So that would, indicate what is going to be your milling breakage. So if it is broken there, then there are 2 things that you can do. Either reject that or send that particular lot for parboiling. So parboiling does all this healing job. So that's how it was taken up. Now, parboiling process you are all aware. I hope you know. Yes, no? I don't know.
No, I don't.
You don't know, okay. In parboiling what we do, we soak the grain in hot water. That is our present practice for about 6 to 8 hours. Take out that soap water. Then these grains are taken for steaming. They are steamed. And then after steaming, this paddy is taken for drying. So the moisture content would have been say 13% at the start of the process. And after parboiling, the moisture content would have gone to about 30 to 35 or even more % moisture. So the moisture has to be removed. So we remove the moisture by passing hot air. Then we bring it to the safe moisture level, and then that is taken for milling. So the effect of soaking time and soaking temperature and the steam pressure and the steaming time has a direct bearing on the amount of cracks that is induced into the grain. The quality of rice also varies because of these unit operations.
That means educating the persons directly involved in milling operation. Perhaps they are class 8 or 9, maybe less than that. I think there is
That's the biggest requirement of the country today.
But sir, nowadays mills are so automated. All these are automated.
No.
You take the worst of paddy, put it in the best of mills, you will get the best of brokens.
What is soaking time, soaking temperature are all automatically controlled.
No, you don't have automation in this.
It should be just.
It has to be manually looked into. Why I can't do that? Okay, your question may be taken in this sense as to why CFTR I can't do that. Look into the structure of paddy husk. Paddy husk is 99% silica. It is so abrasive, they use it to machine engine bores. So it can eat through any metal. So I put a sensor, in half an hour the sensor doesn't work. It's worn out. Non-contact methods. Non-contact methods on a moving mass is a problem. So there is something that is moving, and in that I am trying to put a laser light and trying to get the moisture. No, I cannot do that. These are the inherent problems.
How many rice mills are there in West Bengal?
In around 1200. Around 1200.
And each mill would have how many of these people working? Of course, it varies.
That capacity is never increasing, and most of them are not so modern.
So obviously there will be a lot of labor
One
force.
particular region, what he is
About 20. So 20 to 1200, about 20. No more. 25,000 people. So the capacity building of these 25,000 people is the task.
Yeah.
Nobody takes ownership of that.
That's the point. That is the point I was trying to raise. Who can institutionally do this capacity?
In theoretical terms, that should be the prime concern of the food processing industries. Unfortunately, they do not. And when a rice miller goes to the collector, normally the district industry center takes care of it. But the district industry center just concerned with the development of these mills. What these mills will, how much efficiently they will perform. Sometimes they point fingers at food and
Is it
supply
possible to
department.
initiate a dialogue with West Bengal Chamber of Commerce or whoever represents the rice milling industry?
Rice milling industry, there is a confederation, and they regularly interact with food and supplies department for what knows why. For development of food and
Levy is the major thing.
Food and supplies contributes nothing, and they are
So earlier, yes, there was a mechanism of regulation because of the Rice Milling Act. Now that it has been taken away, there is no control.
There is no control, there is no father, and as such, we think something has to be done for the development of rice milling industry for the benefit of the farmers,
As well as the millers themselves.
and also for the millers also.
Yeah. And what he says is very true in the...
after the abolition of repeal of RMI Act, Rice Milling Industry Act,
He is also telling that.
we have no control over
no control. And the second thing is, the mechanic in that mill was the boy born in that mill because his father and grandfather were working there.
Absolutely correct.
When we were playing with marbles, he was playing with nuts and bolts of that mill. And what has been taught to him by his father is what he is practicing. That's all. He doesn't know anything beyond that. That is the problem. And the other problem also has been faced. We had one center at Mangalore which was training people in the rice milling industry. So some rice milling industry people, they sent their mechanics, जाओ भैया वहाँ ट्रेनिंग लेकर आ जाओ. ट्रेनिंग लेकर आ गया तो दूसरा कंपनी ने उनको किडनैप कर लिया. He was hijacked.
Some rice mills are there in West Bengal which are modernized. And they are multi-purpose project. Multi-purpose or captive or rice bran oil they are producing, etc.
Yes, there is I think a cluster of rice mills.
But if it is compared with Punjab, the rice milling industries of Bengal will put up a big
Yeah, but at least there has been a concerted effort to bring about some semblance of zero energy concept. But this industry, I tell you, wherever I go, I keep talking to these rice mill owners association and things like that. So I keep telling them, you are one of the weakest associations in the country. But the Wheat Milling Federation is one of the strongest. Not that these people are aware of it, but their infighting is so much. District-wise also, I have found that this district association will not cooperate or join hands with the state associations. So that is a reality. And any improvement that one rice mill does, he will never tell it to anybody else. And he sees at any cost, even at the cost of paying more money to his mechanics and people there, he will see that that information is not leaked out. So, unlike in the farming sector wherein people are more open, here it's more closed. So, it's a very different scenario altogether. Yeah, these were all the things. I was just sharing one point with my friends in the morning that in Kerala there is one very progressive rice miller, KKR Mills, who is exporting rice. So what he did was he is milling the rice in such a way that in the groove of rice, there are two lines that you can see in the rice. He is retaining the bran layers there. And this rice variety is red in color. The bran layers are red in color. So you can see two lines on that rice. And you know what his marketing strategy is? He says, vitamin B, retained rice. Now he is not stating anything, no lies. He's giving a factual statement of what he has done. So all these things have got a bearing on now. So yeah, and that is very nutritious. It is sweet to taste, and that's the reason why I am going very faster than anybody else you can think of.
So I can compete with you.
No. You have much more than me. Next time you see me, I'll be competing with Mahatma Gandhi. Don't worry about that. Okay, let's take the most important thing, that is drying. This is where quite a few damage that takes place. So your moisture content of freshly harvested paddy is about 20-24%. Parboiled paddy goes to 33 to 38%. So we all bring it down to 13-14%. So you know the reasons of, what happens because of high moisture, and I don't have to explain that. So 12-13% is what we recommend for 1 year of storage. Beyond that, 11-12%. Now, bringing the moisture content from 20 or 30% to say 12-13-14%, there are problems. One, the grain is hygroscopic. It absorbs a lot of water. But air is also hygroscopic, and it's a mixture of gases, therefore it can also absorb water. So if you bring about a difference in the vapor pressure of these two, so then drying can be achieved. So that means you bring it in contact with air, which has lesser moisture than that of the rice. Give it some time, then the moisture will migrate from the grain to the air. So this is the theory of drying. Now, how to increase the vapor pressure? Add more moisture to the grain. Then vapor pressure can increase, but that is not going to achieve the objective. So the other way is to heat the grain. So when you heat the grain, the pressure inside automatically increases, and therefore moisture migration will take place. The other way of also doing it is refrigerate the air and pass it through absorbents, and therefore it will be more dry air, and then that can be passed over the grain. Or the best way is to heat the air. So the moisture evaporates, and then that is passed over the grain, and therefore drying can take place. So this is what I was just telling you. So low vapor pressure air in contact with high vapor pressure of grain, and therefore drying takes place. There are so many theories, let us not go into these things. So now one thing we should remember. It's a long text, but I'll give it to you in a very simple way. Now we were coming to this workshop here. We all got wet, and we had to change our clothes. So we put out our clothes to dry. Now take the example of your pants. Now you put a pant to dry. What dries first? Which part of the pant dries first? The leg part, isn't it? The bottom part. Now the pocket parts will not dry. Why? Additional layers. Right.
More water is there.
More water is there. Both are true. And the third important thing is, please remember, drying is a surface phenomenon. So only when water comes to the surface of the grain, only then it can be removed. So there are two things that happen. So the rate at which moisture moves from the center of my pant to the outside of my pant is one rate, the speed at which moisture is moving. The other rate is the rate at which water is being removed from the surface. Now these two speeds are not the same. There is a difference. So the rate at which moisture comes from the center of the grain to the outside is much slower than the other one. Therefore, there is always a moisture differential in the grain. And now we are heating this grain because we want to create this moisture to get out. We are creating this vapor pressure differential. So when we heat this grain, heat creates expansion. Right? So you can see that the center portion, there is still some moisture. That needs time to come to the outside. If I reduce the moisture content from 33 or 38% to 13% in one single shot, I can do it. In one single shot, the center has more moisture, the outside has less moisture, outside is heated, the center is still cool, cracks develop. So it's like a human being, you put additional work pressure on him, this fellow will go crack. Same thing is happening here, no different. He is following the laws of nature. So that is what happens. And another inherent observation is, why do these cracks appear horizontal? Why not vertical? It finds the path of least resistance, one. And secondly, the way the cells are organized in the grain. So you can see there are more hexagonal cells in the center, and therefore on the line of weakness it will be horizontal. So the structure of the grain and how it has been formed is also playing a role here. So this leads to cracks. And this will be inside the paddy. Right? Now I am drying paddy, I am not drying rice. So when it is inside paddy, when I take paddy, it looks like everything is fine. सब ठीक है. शादी होने के बाद ही पता चलता अच्छा इसमें कुछ कमियां था, है ना? So when I bring it to the milling sector, only then I'll come to know, aha, इसमें कुछ है. So that is the reason why we have to do it. So we have to not do. Moisture meter cannot detect the cracks. It will detect the moisture content. Where many methods, it is either capacitive method or inductive method or resistive method or whatever.
Whether it is possible by any other parameters, physical analysis parameters.
By test milling, yes, you can do a test milling. The other one is what I told you about, is to put it under a source of light, a strong source of light detector. So that will tell you how much of cracks are there in the grain inherently. So what we are suggesting is, don't dry it in a single stage. So from whatever moisture content at say about 15-16%, you do it in one shot, it can handle that pressure, nothing will happen. At 16% moisture, that material is not yours. You have to give it some time for it to equilibrate. So keep it in another set of tanks for 8 hours. So in that 8 hours is one shift, you can load this dryer with another lot, and that drying can take place in 8 hours. So then this lot will go there and that lot will come here. So when we do this, the amount of brokens is seen. So you can come down to just 7% brokens if it is in 2 stages. That's very simple. So give it some time to relax and for the moisture to equilibrate and for the stresses also to. So this is why they give LTC. Sorry, sir? No, the moisture will get equalized. So entire grain will have the same moisture content. Outside, inside, throughout any cross section, it will be. It will get equal.
25%.
Broken 25% does not have a
25% negation.
In first stage, you do it in 8 hours. Then keep it for rest for 8 hours, and then again do it.
In case of
So
parboiled, it
It is much less.
Much less.
16% is not.
16%.
You're talking about the FAQ.
The FAQ. I am
Okay.
talking about how much admissible under the normal QC rules.
Okay, it's 25% in the case of raw, and in the case of parboiled, it's only about 15-16%. So that's the reason why there is migration of brokens from Chhattisgarh to Orissa. I've seen this. Orissa mills are quite good, and they are getting the brokens from Chhattisgarh, mixing it with this, then selling it. But tomorrow that is not going to happen, I tell you, because now there is a technology to convert broken rice into whole rice. ये तो latest news है. So what they are going to do is they are going to use nano robots to bring those pieces together. I'm sorry, I'm joking. What they are doing is they are making the brokens into powder, passing it through an extruder, and reshaping them into rice. Earlier at CIPS, we had a plant which was known as synthetic rice.
It will be costly.
No, it is not. Your raw material is very cheap. Right? And broken rice is cheap, one. Secondly, the scale of operations are very high. So that will make it. Now the problem will be now whether to allow this to be used as regular. And it cooks like regular rice, it looks like regular rice. Nutritive value is same as, and in fact it's better because brokens are usually having more nutrition than the white.
Sir, one silly question, sir. Why people do not prefer broken high quality rice, but they purchase?
We are not used to it. We don't use broken rice. We use it in some other place. No? Food habit is like that. See, you go to Thailand, they eat broken rice and export whole rice.
No, brokens are used not necessarily
In food, you make it into dosa. Idli dosa, you make it, no?
Yes, used because you're crushing it. But rural is available for 18 rupees kg if it is broken. But if it is full rice, it's 60 rupees or 50 rupees. But people prefer only low
Because
quality rice of full.
sir, this is what I said, our mindset. I want rice which is white, I want rice which is whole, right? And super fine, cooks like old rice, it should not be new. So we have all those preferences which is mindset.
As we have taken today in our lunch.
Yes. Yes. It has to be like that, it has to be separate, I should see those grains individually. See, these are all the mindsets that we have. And the mindset is somebody also came up with a bright idea that we will fortify this rice artificially by giving it some coating. That project fell right on its face. So why? Because we have the habit of washing rice before we cook it. Now why do we wash rice? I'll give you another example. Tomorrow you will definitely wash it twice. I was in a rice mill in Karnataka, and if you've seen a rice mill, the stream of rice comes in and you have a big heap, right? And dog came, did its job and went there. And I was seeing from a corner, I was seeing what this mechanic is going to do. He took that big metal bin and he mixed up this and he equilibrated the moisture.
He takes away everything.
He mixed everything. So some portion was yellow, he made everything yellow. So today that's why we always wash rice. And that is our mentality. And this is reality. So resting is important. So this is what I was telling you. So you have shrinkage and compressive stresses in the inside and expansion and tensile stresses on the outside. And therefore it cracks. So that's the reason. So all said and done, this is what I was just talking to you all about. Surface evaporation is faster. Diffusion is slower. So moisture differential and temperature creates those stresses in the grain, and therefore it cracks the grain. And this drying rate is therefore very, very, very rigid. So that's the important take-home message. Okay? Milling. Best of the mills, with the worst of paddy, will still get you though. So it's what they say, garbage in, garbage out. So if you're giving them bad paddy, then there's nothing you can do. So these are the unit operations in rice milling. So we have cleaning, dehusking to remove the husk, and then separation of paddy and rice because 100% dehusking is not possible. Then whitening is usually whitening or polishing or debranding, you call them, are all the same. Graded to remove brokens, and then you have head. So this is the flow diagram generally. Now when the technology came to India, it came in from two companies, Shule and Setake. initially, way back in the 60s, I'm talking of, probably even before I was born. So Shule was from Germany and Satake is from Japan. Shule gave the technology to a company called Dandekar Machine Works, which is in Bhiwandi, in Maharashtra. And then Satake gave their technology to Binni Engineering Limited, which is in Chennai. And then these companies were the initial companies which were manufacturing rice mills in the country. And then, of course, as is expected in India or anywhere else, marriage of these two people took place. So you had a hybrid of machines. Jugaad is one, and marriage of these two technologies. Now, if you look at these two technologies or machinery, the unit operations are the same, but the machines that are used for these unit operations are slightly different, using different principles. The difference is only in the paddy separation and second one in the polishing or the whitening section. Rest of all are the same. Then later on we have other companies also now, that is Buehler has come in, so that's a Switzerland company, and then you have Chinese mills today. So even they are also into the market. And of course, hybrids. So the cleaner is from Shule, the rubber roll chiller is from Binni, and the polishers are from China. Paddy separator is from Buehler, things like that. So you can think of any combination. And now, what happens is, we have this paddy, and we are putting it through this mixture of machines, and we don't know if it is suited for that variety. And as you were rightly pointing out, he's not been trained on this, and therefore some amount of brokens are to be expected. So let's see some of these in a little detail. First is a magnetic separator, so we can separate the magnetic impurities. There are two types, so the second one is better. So wherein it is continuously self-cleaning. So if you want me to go into the details of this, I can go, but I leave it to you, only to your interest as to how much you would like to know about this. Then cleaners. See, when these cleaners came into the country, if the rice mill was of 2 tons per hour, the cleaner would be of 4 tons per hour. Because these cleaners were designed for only about 2 or 3% impurities. When it came to India, these machines had to undergo paddy with a decimal shift in the percentage of impurities. So instead of 2%, it was 20%. So these machines, they could not handle that load. So then what they did, so for a 2-ton mill, put a 4-ton cleaner capacity, because it was not able to handle it. In paddy, except for a human being, I have seen everything there. You got my point? Except for a human being, I have seen everything there. PD ka ek tukda hai. You want a nut or a bolt? Hai. Kisi ka railway ticket? Hai. You name it, it is there in paddy. And this cleaning machine has to do the job of cleaning.
These are all foreign machines.
Whether it's foreign matter or Indian matter, it is there. And you expect this machine to do this job. So what happens is, see, paddy is such a grain wherein it has got spikes on it. If you look at it very closely, it has got some small spikes on it. So dust gets locked into them. You take clean paddy that has come from the best of the cleaners, and again you pour it into this room, you will find that dust will again emanate. So it is not possible to clean paddy to the maximum level that you are thinking of. So you can't think of an HSCCP for paddy cleaning. So it's not possible. So there is some dust that is always there, and anyway this is being removed during the husking, so it doesn't affect us. And therefore,
Again and again,
kitne baar karenge, sir? Your capacity will go down, the amount of money you are investing on the electricity will go down, the labor is already so intensive. So what happens to this? So it adds to your processing cost. So now I think this is the stage wherein the price of paddy, the price of a bottle of beer and the price of a liter of petrol is the same. Right? Even tomatoes have come there, I think. So all of these are in the same range, 75 rupees. 75 rupees में क्या मिलता है? 1 किलो टोमेटो, 1 बॉटल बियर और 1 किलो चावल या 1 liter petrol भी मिल जाएगा. So all that is as it is putting a pinch on us. So that's going to go. Yeah, please sir, please. Okay, all the best. Have a safe journey. So this is usually reciprocating sieves which have to be used for cleaning paddy. So first we remove impurities which are bigger in size, then we remove impurities which are smaller in size, then we get clean paddy. But then what happens to impurities which are of the same size of that of paddy? That is not removed, and that is usually stones. So lighter impurities are removed by air, and the impurities like stones will remain in the paddy, and that is removed by a de-stone. Then you come for dehusking. Earlier we had these machines. Now these machines are not much in use. Very rarely you can see such dehuskers. So it was nothing but our chakki that we used to do. Dharmendra used to say in one of the movies, piecing and piecing. So this is a piecing mill. So when we were telling about these technologies to these millers, I have to make him understand. So the best example that I would give is the example of Amitabh Bachchan and Jaya Badri. So if I set the mill for Amitabh Bachchan's height, Jaya Badri will just walk through because the height difference is so much. But if I set the mill for Jaya Bachchan's height, Amitabh Bachchan's chest is cut off. So brokens will result. But now these mills are not there. So that's how it is. This is the most important piece of machinery. Rubber roll chala. So consists of 2 rubber rolls rotating in opposite direction, and the rolls have a certain hardness, and the gap between the rolls is half the thickness of paddy. One is rotating fast, the other one is rotating slightly slow. So since the gap is less, there is a speed differential, so you have shear and compression. So it's compression and shear. So because of this, dehusking takes place. Simple, very simply explained. That's it. So many problems are there in this. Now when you have compression and shear, and there is a lot of friction, there is heat generation. Now heat and rubber are friends. Or what? Are they friends or enemies? Yeah, they're enemies, right? So more the heat, softer becomes the rubber, and therefore its wear and tear is more. Therefore, you should not allow heat to develop. One. When wear and tear takes place, the one roll which is rotating faster will wear out faster than the other roll. तो उसके वजह से क्या होता है कि then you will have what is known as kawali. कवाली में क्या करते हैं? So there is no shear. We're just pressing it and it will come out. So then what happens? Dehusking efficiency comes down to 0. Because one roll has become smaller. Therefore, what you have to do, every 8 hours, you have to interchange the rolls. So this has to be taken care of. And the hardness of the rolls is very important. And if the hardness is more than what is actually specified, which is called shore number, S-H-O-R-E. So if it is more than 85-90 shore hardness, then the rubber is very hard. It will break the clay because there is both compression and shear. If it is very soft, it's very good, but it wears out faster. So these soft rolls are used for basmati. It's a very premium product, so they don't mind spending some money on the rolls. So this is how it has to be looked. So, and another thing is, rubber like wood has got a certain aging process. So if it has been produced today and I use it today itself, the yield is only about 80%. But if I use it after 3 months and between the 3rd and 6th month, then I get the optimum life of the rolls. Beyond 6 months, I don't get the optimum life. So then the question is, how do I make out the age of the rolls? ISA mark. So that will have the date of manufacture.
Are our rolls costly?
No, sir, they're not costly. So you have a rolls which have got the ISA mark. So use it between the 3rd and 6th month. So just because the election is coming and then the rubber prices may go high, we tell the millers not to buy 1 year stock of rolls and keep it, because after 6 months you're going to get lesser yield and therefore you'll be paying more. So husk separation is by either blowing it away or by sucking it away. So there are inherent advantages and disadvantages of this process. Okay, paddy separation. Now there are two basic things. You have paddy, you have rice. So what are the differences between paddy and rice? The spelling is different. Then husk is there, and therefore what is the difference in the physical properties?
Density.
Right, density is different. Shape is different. Color is different. And another one, another two things. One is the friction. Okay, friction is different. And the other most important thing is the bouncing properties are different. So if I drop paddy and rice from the same height, rice will bounce more, paddy will bounce less. So making use of these differences, so the bouncing property as well as the friction property, this compartment separator works. So you have compartments, so you can see the zigzag channels there. If I can use the mouse there. Yeah, these are the zigzag channels here. So the channels are zigzag in nature. So this is called one channel. From here to here, this is one channel. So horizontally you have many channels side by side to increase the capacity. So each channel can handle about 40 kg per hour. So not only horizontally but even vertically you can increase the number of channels. So it can handle tons and tons of material per hour. So rice bounces more and the stable is inclined and it oscillates. So rice bounces more, it goes down. Paddy bounces less, has got more friction, it comes to the top. And therefore separation can take place. This is a very simple way of putting it. If you want me to go a little complicated, I have to solve 35 to 40 simultaneous equations to decide on the motion of each particle. So that's the extent of work that has been done. So this is a very simple way of doing it. So we should have equal feed in all the compartments. And variable stroke. Stroke is the distance to which it moves. So it can be just this much, or it can be this big. This is preferred because of variation in the variety that we handle, or the variation in the moisture content. So that is required. And it should have equal acceleration with no jerks. So when it goes and then it comes back again, so there should be no jerking when it changes direction. Otherwise mixing will take place. So these are all finer tips. So we separate the paddy and rice. Now that's the Dandecker method, and this is the Binney method. So it uses dimples. So length is the most important criteria here. So paddy is longer than rice, so it sits in the dimples when it is moving up. So the rice will sit in the dimple and come to the higher end. Paddy will not fit into the dimple, it will simply slide down and go to the lower end. In the middle you will have a mixture which will come back again for separation. So this is a Binney type of method. And this is having multiple trays to increase the capacity. Most important. Separation, there are no problems for increasing the broken content, but here is the reason. Now there are two types of polishing that takes place, polishers that are available in the country today. One is abrasive, that's the second figure. The first one is friction. So in the second figure that you see, there is a sharp material which scratches the bran layers, and bran layers are therefore removed. So this is one way, like what we do, or most of our men do here. We shave with a blade. That's what we do. So we are doing the same thing here. So we are shaving each of these grains with multiple blades to remove the bran layers. And in the second method, friction between grain to grain is made use of to remove the bran layers. So usually what the rice mill industry does is, it uses abrasive method for initial bran removal, and the final bran removal is done by friction. Because when we scratch out the bran layers, they don't come out as dots or powder, they come out as flakes. So even though it is physically removed from the rice, it is still sticking to it. Electrostatic precipitation or electrostatic method, it is still sticking to it. So it is still there. And that is removed by friction polish. So here, what we have to know is, the more the number of polishers, the better. So how much more? Now, let us look at the energy requirement. These polishers consume not less than 75% of the total energy of your rice mill. So if your rice mill is consuming 100 HP, these polishers consume 75 HP. So if I increase the number of polishers, my electricity bill is going to go higher and higher. So then I will do one thing, I will do it in one polish or one polisher. Then my broken percentage will be the maximum. Because what are we doing? We are trying to apply pressure on the grain to remove the bran layers. Now the more the pressure, more the chances of breakage. More gradually I do it, lesser brokens, but more electricity bills. So this is where we trade off. So usually good mills have about 3 polishers. Good mills. Really good mills go to more number of stages, like for example basmati. So they go for more number of stages to remove the bran. And what are the types of polishers that we have in the country today? Oh my goodness, there's so many. Even in abrasive and in friction or in combination, there are so many different types of polishers. We still don't know which polisher to use for which variety. Nobody has done the study. We don't know. So, how is it done? बगल वाला लगा दिया, उसको सही चल रहा है, तो हम भी वही चलाएंगे. बस उतना ही है. So, there is no science that is involved. So, look at these polishers. Cone polishers, which are very highly prevalent in parboiled rice areas. Abrasive polishers, which is the Binni type or the Satake type. Vertical polishers, again there are 2 types in that. These are all abrasive polishers, mind you. Vertical is again 2 types. From top to bottom and the another one from bottom to top. So 2 methods are there in that. And then there is a verticone polisher which has been done recently by Shule. And then you have a horizontal friction polisher. There are so many different types of polishers. So,
Only to remove the
bran.
only to remove the vitamins.
Yeah, to remove vitamins or to remove the bran layers.
To be frank, anyway, single polishing is not required. Only for color you are doing that. There is no
See,
other.
why do we remove the bran layers is because we cannot digest the bran. Our digestive system.
What is digestible? One polishing is required.
Yes, there is a minimum polish required. So how much is the question? 5 to 6% is sufficient. Now, we have a situation of 5 to 6% of polish. I take this rice, I bring it into your FCA godowns, I keep it. It will not stay there for no more than 1 month. Shelf life is very, very low. Why? Because the moment I touch the bran layers, lipase has come into contact with oil. That activity, chemical reaction starts taking place. Yes, please, sir.
Is this, sorry for the slightly it's a peculiar observation. Is this part of the curriculum of the ITIs and polytechnics anywhere?
If there is food technology as a course that is there in that thing, yes, it is a part.
No, there is no food technology. In polytechnics, I don't think food technology is.
No.
No, but do you think that there is a need for integrating part of this into the ITIs? Not as a full-fledged program, but maybe as some kind of a paper or some kind of a course in the ITIs?
Definitely it will be useful. It will definitely be useful.
I think we should start thinking about some of these things in a long-term basis.
Education at any level is definitely going to be helpful for
because they will
all
not work
concerned.
in the rice mill as such.
Yes, but awareness is created.
They will certainly act as some kind of a.
It affects so much power. So we should like awareness of the consumer. There could be some use of power will be minimum. Huge type of polishing is not much required. So consumer should just rice has a very short shelf life.
Yes, it's got a very short shelf life. No, we are moving from medicines in the form of tablets or injections or whatever, and we're looking at food as a vehicle for delivery of these things. So that has become another area that we're looking into. Okay. So this is how a cone polisher works. It's an inverted cone having a abrasive surface. On the outside you have a stationary wire mesh cage. So the grains are caught between the abrasive surface and the wire mesh cage, and therefore bran layers are removed. And whatever layers of bran are removed, they fall outside, which is then separately collected. So this is a cone polisher. So you will have many of these polishers. Okay. So 1, 2, 3, 4. Cone polishers, they usually use about 4. Good mills in Orissa I have seen. They use about 4 such polishers. And these are capable of handling very high tonnages also. So they can give you about 6 tons per hour, 8 tons per hour you can get from these polishers. We have also gone into these ingredients. If you're interested, I could go through these things, how much of, what is the grit size that we are using, what is the salt, what is the cement, whether it is natural emery or synthetic emery. So all those things have been there, and we are giving this to people and educating the millers on the use of these things. That's what I said. So, percentage of natural and synthetic emery that is being used. So even that can, because synthetic emery is slightly costlier than natural emery. So like our grinding mills, you have seen grinding mills, so usi ko hum yahan istemal kar rahe hain. So the size of the particle there is different. So in the grinding mill it is very fine. Here we are using it almost like sand. You know the sand size, so it's almost like that. So we have gone into all these things. How much it should be for the first cone, second cone, third cone, etc. What are the speed differences? So quite a lot of work has gone into it. This is a horizontal abrasive polisher. It's like our, I would give an analogy of a pressure cooker. In a pressure cooker at home, so unless and until the steam inside, the force of that steam is more than the weight that is kept on top, the steam will not come out. So here also what is happening is the rice is coming in from the right hand side. There is a screw element which is pushing it towards the door. Now there is a door at the exit, and on the door there is a weight, and that weight can be changed. So unless and until the force of the rice is equal to the movement of the door will not open. So that much of pressure is created, and this brings about polishing of the grains. So this blue portion that you see is abrasive material, and to remove the bran, air is blown through from the center. So two things happen during polishing. Heat is generated, and heat generation is detrimental again to our rice, right? So rice temperatures can go as high as how much? Ambient temperature is 25, say 30. Rice temperature is, sometimes it goes up to that 50. You can see it steaming if the moisture is there. 50, 60 degrees Celsius we have seen. So there is a simple thumb rule which we keep telling the millers. Every 1 degree rise in temperature beyond 40 degrees centigrade, gives you 5% more brokens. So that's why I was telling you yesterday, there was one progressive rice miller who was a 4th standard pass. He had the entire rice mill air conditioned. So they used air that is going here, that is refrigerated air. That luxury even I don't have. So that is the type of involvement that they have. So they cool the rice, and it is done in multiple stages. So this is abrasive method. So abrasive method is just scratching the surface and removing the bran leaders. So after 3-4 stages of this, then we have the friction method to only give it a shine. So give it that fine appearance. So this is given by this friction machine. So grain to grain rubbing removes the sticking bran. So that's how it is done. Okay, I'll not go into this. This is next is grading. चलनी में डालो, छोटा छेद होगा तो छोटा ब्रोकन्स निकलेगा, बड़ा छेद होगा तो बड़ा वाला निकल जाएगा. तो हमको जो हाथ में मिलेगा पूरा 100% length of rice is what we are used to. In India, I think the classification is 75% and above is whole rice, isn't it? So we grade it that way, remove the brokens. Basmati industry uses this. Now, a rice grain has 3 dimensions: length, breadth, and thickness. So this is a this is a lengthwise grader. So based on the length of the rice, grading takes place. So you can see the cylinder here, which has got dimples in them throughout the entire surface. So the brokens can sit inside the dimples. So when the cylinder is rotating, the brokens are discharged at a higher point, and the whole grains are discharged at a lower point. So the size of the dimples are depending on the length of the brokens. So 1/8 dimples are there, 1/4 dimples are there, then 1/16 if you want, you can remove the brokens. So basmati is always 100% length of the rice. So that is used. So these are known as tire cylinders, and you will have like a double-decker bus, you have multiple decks one above the other to remove different sizes of brokens. Bran separation is very simple. I'm telling you it's simple, but it's not as simple as it sounds. Simple in the sense, I suck the air, bran particles are easily lifted out, and they are put through a cyclone, and separation takes place. But there are lots of problems in this. If you take parboiled bran, the oil content is very high, so the bran is very sticky. So it will stick to the surface of the machines and on these pipes. So the best way to remove that is how to remove that sticking bran. Hitting it with a hammer. Bas. Jara pipe, laga, hathodi mein maar. And the best way to find out if a rice mill is working or not is to look at the pipe. For material movement from one machine to another, you look at the pipe. That's the best way you can find out if that machine is working or not. So wherever paddy is coming, it takes a turn and then there is a bend. At the place where it is bending, you will have one gunny bag tied there. Kyun? Because when paddy has come and hit that pipe at that corner, then changed its direction, because of constant hitting, that pipe has become an opening there. So he has to replace that bend. So again it will go. After 1 or 2 months, again it will go. So what he will do? Take one fata hua gunny bag, tie it there with a thread, and keep it there. So that is the best way to make out whether a rice mill is running or otherwise. Okay. So bran, there is, and in fact we had one small study that we tried to do. We used glass instead of metal, and it miserably failed in one mill. Why? The cyclone was made out of glass, so you could see if the bran is sticking there, and then the smoothness of glass is much better than that of metal. So we thought bran will not stick there, and therefore it is easily removed. बट पुरानी आदत है, हमारा मैकेनिक आया, ग्लास है, मारो धैड़, तो वो पूरा मशीन टूट गया. So then he said, okay, no more glass. Yes, but that again cost. Again, fiberglass, or if it's fiber reinforced, then you don't get that surface finish that you're talking of. We want a very, very smooth surface finish. Okay? Let's look at the newer trends that are taking place in rice mills. Why modernization? Blah, blah, blah. Okay, you know this better. Combination cleaning. So now people are coming out with a combination cleaning of lengthwise and thickness-wise cleaning. Now, why do you need to do this grading? Now, I take paddy. The variation in length is about 150%. The variation in thickness is about 200%. So, all this is coming into the mill. And there are different grains of different sizes that are coming in, and therefore setting the machine itself is my biggest problem. Because I have to set it for the smallest grain also, and we do not accept rice with even one paddy in it. We reject it. Yeah, acha nahi. So, I have to remove the husk and bran from even the smallest grain to the biggest grain within the same variety. You take the same variety, there is a variation. So if I grade this before it comes to the mill, I can collect all those smaller grains, keep it aside until it becomes some sizable quantity, mill these grains of the same size, and then get good or better yield. And second thing, our scientists are slightly intelligent. They did a nutrition study on these grains, and they found that the smaller grains are richer in nutrition than the bigger grains of the same variety. So then they said, don't sell it at the same price, you sell it as premium high nutrient rice. So that's possible. So within the same variety, the size also has its effect on the nutrition. And therefore, because of this grading, what happens? All the grains are of the same size. So my machine setting is paka, polishing is paka, energy consumption comes down, it's having better process control, and most importantly, it will be so nice if all of us were of the same height. All of us 6 feet tall and 80 kg weight, it will be so nice. That will look nice. So that's the advantage of it. Rubber roll sheller has gone through a lot of automation today. It's totally automatic. You don't need to stop the machine now. Automatically the roll interchange takes place. Individual motors are there. And the roll pressure is not by using springs, which is old. So it is by pneumatics. And such things are also there in the country. And we did not want to lose the race. So we did some work. Automation we have done of a rubber roll sheller, which is not infringing on any patent. So we have done that. So we put a light source on top and a sensor at the bottom. The shadow of the roll is falling on this sensor. So when the roll keeps wearing out, more and more light is falling on the sensor, and that is used through a computer to change the roll speeds, etc. So that has been done. Paddy separator. Now you have chromatic sensors. You have chromatic sensors and servo motors, and it will adjust everything automatically, having a camera that is fit onto the machine. This I have told you about. This we have told. So even polishers now today have cameras fitted onto it, which will determine the degree of polish that you want and set the machine parameters accordingly. So such machines are also possible today. So this is how it is. And then there is one more version, which is counter rotating screen. In the earlier machines I was telling you the screen is stationary, but here if the roll is rotating clockwise, the screen is rotating anti-clockwise. So the claim is that it gives more percent polish for the same unit operation. Automatic paddy separator, again with chromatic sensors in it. So no human beings required. So it will see the paddy and set it. Yeah, this is what I wanted to say. See, for example, you give me the rice, I will choose the machine and the machine parameters. So if the rice is round in shape, then I can choose what is the peripheral speed, what is the grid size, and what is the pressure. The other way around, you give me basmati rice, I'll pass it through my machine at a certain condition that all basmati rice will look like bearing balls. So we can shape the rice in polishers. So that is also possible. So this is how it looks like. So this is the camera which looks into the rice that is flowing down and sets all the parameters. So today everything is e-governance and internet related, everything sitting here itself. So there is no time for doing everything because everything has to be done on my smartphone or it's on the internet or it's on the computer. Either it's online or offline or whatever. Everything is to be done there. So this is the latest polisher which is on a silky polisher which is now coming into picture. So if I have to clean my specs, what do I do? And then so what is happening here? There is moisture and then there is friction. So that is same thing that is done here for these. So moisture and friction is given. So there is a surface level, nano level of parboiling which takes place, which gives it a very fine finish. So this was named after Silk Smita. अरे भाई साहब थोड़ा हंसो तो सही because it is so smooth. अगर चावल को हाथ में लेंगे और थोड़ा सा ऐसे खिसकेंगे उसको वो आवाज आता है. So the people who named it, they call it a silky rice, maybe after her, I don't know. So and you have color sorters today which will see the rice from two directions, from front and from back, and then even if there is one dot which is not desired, there is an air jet, poof, it will be blown out. So such systems are there today, and each channel, there are channels in each, one by one rice grains will come, and the camera catches those images from front and back, compares it with its memory, whatever you have set. So if you want white color of a certain degree, you can set that color. Any deviation, a little off-white, even that grain is rejected. Okay? And one by one it sees this. And what is the capacity of this machine? Each grain at a time it is taking pictures, comparing it with the set memory, and then whether to accept or reject is decided by the computer there. It works at the capacity of 6 tons per hour. No, regular, ordinary people also are using it. Now all the rice that you are getting is color sorted rice. Earlier the cost of this machine was something like 60 lakhs or 1 crore, which was imported. Today Coimbatore and Ludhiana fellows are doing it with 1 decimal shift to the left. Yes. That's why everybody is using it. And you know what they are doing? If I go to a mill, I find that he has one paddy separator which is a China make. He uses it for 1 year. When the season ends, he will throw it back as junk to the steel industry. And the same company is telling, अरे मेरे को वापस बेच दो, 25,000 दूंगा, नया वाला खरीदो 1 लाख में. तो नया हर साल देख रहा हूं कि नया मशीन खरीद रहा है वो. मैंने बोला क्यों इसको रिपेयर में क्यों नहीं करते? सर रिपेयर के झंझट में क्यों पड़े हम? पुराना मशीन को 25,000 में वो ले रहा है, तो आई एम सेलिंग इट बैक टू हिम. सो टुडे नोबडी हैज टाइम. ऑल ऑफ अस आर नाउ वी आर लुकिंग एट इतना टाइम हो गया, साहब वहां से बता रहे हैं टाइम हो गया. देखो ये वो जाने के लिए टाइम नहीं है हमको, वहां पर भी कंप्यूटर चाहिए, वहां पर भी हमको टेलीफोन चाहिए. वो फोटो देखा आपने? आया कुछ समझ में? अरे इसके लिए भी टाइम नहीं है. सब कुछ वही. ये जो राइस मिल्स है आजकल सारे के सारे डिटेल्स आपके मोबाइल को आ रहा है. आप बैठे हैं थाईलैंड में या ऑस्ट्रेलिया में, मिल चल रहा है यहाँ पर, और वहां से इंटरनेट से आप सब कुछ चला सकते हैं. हाँ, automated, totally automated. Nobody is required, only one fellow is required, that's all. So that is the status of rice milling today. So that's how it was, and this is how it is today. Multi-story, I was telling you, 120 tons per hour, that's how it will be. All shellers in one line, all polishers in one line, polishers in 3 floors, graders in 1 floor, everything automated. Everything automated. Sab kuch. Hope this has thrown some light on the matter. We're glad to answer any questions if any.
How much is required for totally automated rice mill?
200
Depends again on depends on capacity. Talk in crores, please. 100 crores and above. But people are investing. So I went into a company called Miltech in Bangalore. He's developing a polisher. Each one is 80 tons polisher. I have never seen such thing. It's half the size of this room. One polisher, horizontal polisher, half the size of this room. It's huge. And millers are putting it up. 20 tons, 40 tons, 60 tons per hour. Gone are the days when 2 tons per hour mills were working. No? It's gone. They are going to be wiped out. All these elephants. So when this fellow comes into the market, he is going to take all the paddy in that area. Decline, yes. Better quality will come in. Of course, it all depends on the minimum support price, this, that, etc. But then some small mills also continue to exist in some rural areas. We cannot say no to it totally. But then in progressive areas, it's taking away like mad.
Sir, what is the latest thinking on use of paddy husks as byproduct?
Many things are there, sir, and use of paddy husk. That itself could be a lecture for 1 hour. In brief, let me tell you. Using it as a source of fuel is one thing. But if we use fluidized bed furnaces, the calorific value of husk is such that 3 kg of husk is equal to 1 liter of petrol. So it's 3,200 to 3,900 kilocalories. So this is one thing that we can do. So what it means is, the energy required for one rice mill is supplied by half the paddy that is obtained from that rice mill. That means that if I have a cogeneration in place, the rice milling will use only 50% of the energy generated by husk, and the rest 50% is supplied to the state electricity grid. So this is the power of husk. 1. Point number 2, it can be used in controlled combustion to produce natural gas, which can again be used in various places. Number 3, it can be used as briquettes. But the briquette, the problem is the transportation of briquette should not be more than 50 kilometers, otherwise it is not economically viable. Proper combustion of husk will give you electronic grade silica, which is used in the industry, chip production. So if we have an opportunity for an integrated use of husk, then byproducts, and most importantly, after burning this husk, now in the conventional method, what to do with that black ash is a big question. Now they are using it as landfills, otherwise it can go for use along with road or tar. The third one is they're using it in the cement industries. So these are all the uses of husk that we can think of. And you have a very important chemical that is obtained from rice husk, which is oxalic acid. So that's also a byproduct that you can get from husk. That is why when you briquette it, there's an oil-like substance that oozes out, which acts as the binder, a natural binder. So these are all the uses of husk. So if we can think of, I think in Bardwan, I'm given to understand that there is an integrated rice mill, wherein there are 5-6 rice mills in that area. All of them are giving their husk to the centralized place. The power is generated there and supplied back to the rice mills. So only 50% of the power is consumed there, and the rest 50% is given to the State Electricity Board. That concept I think we should promote. That is important because we are now dependent on nuclear. Our environmentalists will not allow us to do it. Thermal, we have shortage. Water is always a problem. In our state, Tamil Nadu is always sitting on our head, so we cannot do it there. So these are the areas I think that we should look at, non-conventional energies. So if you can promote this idea and make this concept workable in many other areas. Now, the success of Burdwan, I don't know. If I had time, I would have been happy to go and visit and find out the actual status of Burdwan there. Thank you so much for your time. Yes, please. Sir.
You were talking about the getting of extruded rice from broken.
Yeah.
In India, actually, is it happening?
It's going to happen. It's going to happen. People are coming forward now. Yes, it's going to happen. And it's also going to come into dal. So dal brokens is not used anywhere. So even that they are looking into. So major companies, big companies, of course, they are, at present they are MNCs. But then even Indian entrepreneurs have come. And they are looking at use of these products. Now, they are looking at the size of operation that is viable now. So, they have gone back after a discussion with us to see what is the most viable size that they can put up. So, that is going to be a reality.